Have you ever thought about how people traveled and navigated prior to GPS? I know my grandparents used cars, trains, planes, and buses, much the way that we do now. But what about their grandparents, and their grandparents, or their grandparents? Today, many of us are dependent upon technology to find information about traveling.
Okay, Google, how do I get from London to Paris?
Paris, France is 5 hours and 38 minutes from London, UK by car and light traffic. Here are your directions.
Okay, Google, how wide is the English Channel?
According to English Channel Swimming, the English Channel is approximately minus 19 nautical miles or 35 kilometers wide at its narrowest point. Most swims are a little longer to the landing on either side.
It wasn't all that long ago that lighter-than-air crafts like zeppelins and hot air balloons were the only vehicles in the sky, and ships were the only way to voyage across the ocean. It was in the early 1800s that Jean-Pierre Blanchard first flew over the English Channel in a hot air balloon. So how could a hot air balloon pilot determine his elevation or how far away he was from his destination? One method would be to use a tool called a transit or a sextant and some basic trigonometry. This is also how seafaring ships could determine their location when out of sight of land. It takes a bit of planning. Here I've placed two markers on the ground 10 meters apart to simulate what the balloonist might have used to determine their altitude.
If a balloonist wanted to find his altitude above the ground, he could use the two markers placed on the ground and his transit and a little bit of trigonometry to figure out what the altitude was. In this example, we have two markers that are 10 meters apart, and using the transit, which can measure an angle from a perpendicular to the ground, the balloonist sees that the first marker is at 26.5 degrees, and the second marker is at 37 degrees. Since our balloonist is familiar with the use of a transit, we can assume that he's using a formula that relates the angles found by the transit to the altitude of the balloon. One example is a formula that says the altitude is equal to the distance between the markers divided by the tangent of the larger angle minus the tangent of the smaller angle. So if we use the values in this problem here, we find that A, the altitude, is equal to 10 over tangent 37 minus tangent 26.5. We could calculate this, fortunately for us, using a calculator, but for a balloonist, more likely a table of trigonometric values or a slide rule. If we solve this equation, we find that the altitude in this case is approximately equal to 39 meters, and so the balloonist is floating at about 120 feet.
While this example might not be particularly applicable today, it does help demonstrate how these skills have been used over the centuries and helped shape our world. Thanks so much for watching.